Welcome to Solving Equations. In this video, we are going to look at one-step equations and solving them by using addition or subtraction. Let's start off by defining the word equation. An equation is a mathematical sentence stating that two quantities are equal. A quick example would be 3 plus 2 equals 5. 3 plus 2 on the left is one quantity, and it's equal to the quantity on the right, which is 5. Next, we need to define solution. The value of a variable that makes the equation true is the definition of solution. Let's look at our previous example, and let's substitute 3 with x So the solution of this equation would be that x equals 3, and that's the value for the variable that's going to make our equation true. When we are working with equations, we need to think of them like a balanced scale. The left side must equal the right side. So if I have an equation, x plus 8 equals 12, I know that on this side my x has to equal 4 plus 8 equals 12, so that I can say I have a balanced scale. 12 equals 12. Okay, so on this screen I have asked that you circle equations that are equivalent to x equals 3. So you're going to look through the equations, replace x with 3, and see if the equations are true. Go ahead and circle these on your notes paper, and then we'll check these tomorrow in class. So now we have a little word problem. Robin had some video games, and then she bought 4 more games. Now she has 10. This scenario can be described using the equation x plus 4 equals 10. So I've asked you on the paper, what does the x represent in this problem? So why don't you go ahead and write that out on the line that's provided for you, and then we'll check this tomorrow in class. What are inverse operations? They're operations that undo each other. And you will notice on your notes that I have the word add. Well, what is the operation that undoes addition? It's subtraction. So if you think of it, it could be also thought of as being the opposite. The opposite of adding is subtracting. Also on your notes, I've written a question. Why do we use inverse operations in solving equations? See if you can come up with an answer, and then we'll talk about that. I want you to notice on your notes that I have written a clue undo chart, and the example that I've given you is x minus 2 equals 42. And sometimes students don't see the operation that's going on in the equation, so I tell them to do a clue undo chart. The clue is the hint, what's going on in the equation, and that is, my clue is I'm subtracting 2. So if I subtract 2, how do I undo a subtraction of 2? Well, I add 2. So in order to solve this equation, I'm going to have to add 2 to both sides of the equation. That gives me a 0 pair, because negative 2 and positive 2 make 0. So I'm left with x on the left side, and when I add 2 to 42, I get 44. As we're learning to do equations, I'm also going to have you check your answers. When you do a check, you take what you got for your variable and put it back into the original equation. So I'm going to come up and put 44 minus 2 equals 42. Well, is that true? Yeah. 44 minus 2 is 42. 42 equals 42. So my equation checks. I have the correct answer. When we're solving equations, our number one goal is to isolate the variable. We want to get that variable on one side of the equation all by itself. Next, I want you to try using a clue undo chart. It will help you understand what the operation is that's going on in the equation and help you to get x on one side of the equation by itself. Always use inverse operations to solve, and remember the left side of the equation has to stay balanced with the right side and be equal. Now you solve for the variable. You've got the variable on one side of the equation. You've used inverse operations to get it by itself. So now you solve for the variable. And the last thing that you'll do is check your answer to make sure that it works in the original equation. Well, we have some properties that allow us to use inverse operations when we're solving equations. And the first one is the subtraction property of equality. And this states that the two sides of an equation will remain equal when you subtract the same number from each side. And the example I have is x plus 9 equals 55. Well, my clue in this equation is I'm adding 9. So if I'm adding 9 to both sides, how do I undo addition of 9? Well, it's subtracting. What I have to remember is if I subtract it from the left side, I need to subtract it from the right side. This gives me a zero pair on the left side, and I have x equals now 46. If I check this, I'm going to substitute 46 back in for x and say 46 plus 9 equals 55. Is that true? Yes. 55 equals 55. Well, if I have a subtraction property of equality, I probably have an addition one. So this is pretty much the same thing, only this time it states that the two sides will remain equal when you add the same number to each side. So this time I'm adding. And here my example is x minus 5 equals 13. Well, if I do a clue undo chart, my operation is subtracting 5, so I'm going to add 5. Well, my property says I have to add it to both sides of the equation so I can keep the equation equal. This becomes a zero pair. X equals 18. If I check that, 18 minus 5 equals 13. Is that true? Yep, 13 equals 13. And that's my check. Okay, so I'd like you to go ahead and practice solving this equation. I'm going to do it with you. I'm going to make my clue undo chart, so I'll just put a line down here. I look at my equation. What's going on? Well, I have my clue as a subtraction of 5. How do I undo that? I'm going to add 5, and I will do that to both sides of the equation. So this becomes a zero pair, and I'm left with x on the left side. And when I add 23 and 5, I get 28. I'm going to check that. I'm going to put 28 in for x in my original equation. So 28 minus 5 equals 23. Well, is 28 minus 5 23? Yes. So my check is good. Let's try another one. Clue undo. My clue is an addition of 9. How do I undo adding 9? I subtract 9. Oh, I think we just did this one. So I'm going to subtract 9 from both sides of the equation. This becomes a zero pair, and this becomes x equals 46. Replace x in my original equation with 46. Add 9 to it. Does that equal 55? Yeah, it does. So my answer checks. Here are your got it problems. Be careful because you need to simplify the double negative first. Go ahead and use a clue undo chart and then check your answer, and we will look at these tomorrow.